We're now moving on to the third leg of the stool, the third module, and it's that crooked leg you see on the stool. And the reason it's crooked is this is in many ways the most challenging and the most difficult leg of the stool in terms of bending the curve and getting reductions. You see it's labeled as VMT. That is a measure of mobility. It's vehicle miles traveled, and I'll be referring to that. And I should say when we talk about mobility and VMT, we're also including here land use strategies and infrastructure issues because it all boils down to how much motor vehicle VMT we have. If we look at mobility, how it's evolved over time, in the United States, in California, actually starting in Los Angeles, we've created a transportation monoculture. It started in LA with cars being, playing a dominant role in the growth of our cities and the growth of our economies and changes in our lifestyle. So in Los Angeles grew up around the car, and then other Sunbelt cities followed the same. That's Houston, Phoenix, Tucson. Those cities all were built around the car and are much more sprawled out than other cities in the US and much of the world. So we've created this, what I call monoculture, in the sense that we now use cars for almost everything as passenger travel. Mass transit accounts for only 1% to 2% of our passenger miles traveled. Most of the rest is by cars and our own use of cars. And so when we get up in the morning and we think about how are we going to travel somewhere, most of us, we just walk out to our car and go where we're going. We don't think about the different modes and different options. So we've gone through this history, we've evolved where we have created this monoculture around our cars. In some ways, that's not turned out all bad because as we talked about in the first module, our cars are getting more and more energy efficient. The result of that is that cars now are actually more energy efficient per passenger mile than buses, and thus have lower greenhouse gases per passenger mile than buses, which goes against all the conventional wisdom that you hear in the newspapers and in public discussions. But it's true, and the gap is widening, and that's because cars are becoming even more efficient, whereas transit buses are not. There is now a movement to make buses electric using batteries, and that will make a big difference here as we go forward. And as you can see here, transit, cars, planes are, not so different. The reality and the explanation for that is because we have this sprawled land use. So buses have to go into suburban areas, they have less utilization. So buses in San Francisco or New York have much lower greenhouse gases than shown here, much better energy efficiency. But most buses are not operating in those ways. So as we look forward, our prime strategy is to use cars less, to use them more intensively. That means more people in our cars, but also more people in our buses. And as you'll see, even creating new modes of travel, what I call pooling, also to reduce vehicle use. When I talk about vehicle use and reducing vehicle use, some people get very upset. They think that all Americans have a right to a car and to drive a car wherever and whenever they want. My response to that is many of the trips that are taken are not high priority trips. So if this person in the SUV would get out of their SUV and walk their dog, they would use less greenhouse gases, less energy, and be healthier. And I just want to point out, not just an American issue. This is a slide loaned to me from Pakistan, walking a camel. One of the big options looking forward with our vehicles is to automate our vehicles. And the question is this good or bad from a climate perspective in terms of bending the curve? And what you see in this graph is there's different aspects to it. So if automated cars are driven close to each other in a platoon, they reduce the aerodynamic friction and they operate much more efficiently. So therefore, you see that there's a reduction in energy use. But there's one factor that's really problematic and disconcerting with automated vehicles. And that is that if the vehicle is automated, that means when you get in the vehicle, you don't have to pay attention to the road. You can eat, sleep, you can use it as an office, hotel room, you can tweet, you can do anything you want. And if you can do that, time spent in a car is no longer a big cost. And people would be willing, many people would be willing to live in Tahoe and drive to Sacramento or Davis, where I am, or to San Francisco, because they could work and they could do other things, and the commute would not be so problematic to them. So the result of automation could be, if people own their own automated cars, a lot more vehicle use and therefore a lot more energy use and a lot more greenhouse gases. So the challenge is going forward, and the opportunity with automated vehicles is that we can use these vehicles more intensively and use them as a commercial service so that people can access that whenever they want, but in a pooled way so that they share it with other people. And if we have an automated vehicle that's used, say, 100,000 miles a year, operated by a company like Lyft, or it could be Ford Motor Company or GM or Toyota, then the cost per mile goes way down. And if the vehicle is pooled, meaning more than one person, it becomes even less. The cost of travel becomes very low. Now, the good news about that is more people will have mobility, and that's good. People that are lower income, people that have physical disabilities. And so this is, from a social justice, environmental justice, social equity perspective, this is really good. But it only works if the vehicles are pooled instead of individually owned. And so going forward, the policymakers, consumers have to be thinking about how do we create pooling. And right now, we do have pooling starting. Uber has Uber Pool, Lyft has Lyft Line. They operate that in many metropolitan areas, not all yet. And they are a first step toward this pooling future that will then eventually lead to a pooled electric automated vehicle. And when we, when we get to that point, we are going to see a dramatic reduction in VMT and emissions, even though we'll probably have an increase in passenger miles traveled. But we'll have a big reduction in VMT, vehicle miles traveled, and a big reduction in greenhouse gases. We've seen with vehicles that to bend the curve, the number one thing we need to do starting now is to improve the energy efficiency of the vehicles. We are doing that. We need to continue doing that. And the way we mostly do that in most of the world today is using performance standards. We tell car companies, you've got to reduce your efficiency and your greenhouse gases per mile or per kilometer going into the future, and we lay out a schedule for them. And that's working very well. Going in the future, we'll probably see more market-based approaches as well. Fee-based is an idea where you pay more for a gas guzzler, pay less for a battery electric vehicle. Number two is we need to electrify our vehicles. So the energy efficiency is an important current strategy and policy. The number two one is we need to electrify our vehicles. And that means with batteries and with hydrogen fuel cells. And these greenhouse gas performance standards also work to encourage automakers to move in that direction. And we have other policies, such as in California, we have a zero-emission vehicle mandate. Other countries and states are also adopting it. And we also have a lot of incentives that we use to encourage people to buy an electric vehicle. Going forward, we're going to have to switch away from those incentives because they start getting very expensive. But we will still have a suite of policies to encourage it. And then we get to the heavier vehicles. We haven't talked much about that in this lecture, but the larger vehicles are more challenging in terms of coming up with alternatives to them. They need to be more efficient, energy efficient, but we need other options besides batteries or in addition to batteries for the really larger vehicles, especially when we get to planes and ships. And we need probably advanced biofuels, probably fuel cells running on hydrogen for some of those options. And then the third leg of the stool was reducing VMT. Perhaps the biggest challenge of this bending the curve for transportation really does have to do with the mobility. And as we've seen here, that the strategy probably going forward is using more pooling. Uber pool, Lyft line, microtransit, using buses more intensively. But the problem is, it's become very clear that this is the most problematic because we have seen that VMT in the United States, as well as in Europe, Japan, it had been going down per capita from about 2005 to 2013. But when the economy started recovering in all of those countries, the VMT started going up again. So the net effect is that we now, since 2015, are seeing a steady increase in VMT, not a decrease. So we really need to bend that curve down. Pooling is a key part of that, but the other part of it is creating incentives and disincentives to encourage people to drive less, to pool, to give up car ownership. And that'll be tough because many people use their vehicles for many purposes. They have dogs, they have sporting equipment in it, and that's going to be a challenge. But as we go forward, we think we can create something even better for them with pooling services that are on demand and that most people will transition. You've heard through this entire lecture that transportation is a really important part of bending the curve. It's the largest emitter of greenhouse gases in California in the United States. But there's a lot of challenges. There's a lot of opportunities, but there's a lot of challenges. We do need to commit ourselves. We need more innovation. We need better policy. We need markets and consumer behavior to change. But all of that is very plausible and doable. We do need resolve, and both from industry, from the markets, from policymakers. But I'm convinced we can do it. In fact, we need to do it. Thank you.